Section 7.5, we're on page 485, problem number 33. And problem 33, as you can see, we're trying to find the sine of alpha plus beta, 33a, sine of alpha plus beta. So the first thing I'm going to do is I'm going to write out, using the addition, subtraction formulas, I'm going to write out the addition formula for the sine of alpha plus beta, and that would be the sine of alpha times the cosine of beta plus. So when you have the sine, notice the sign is plus plus, minus minus. So the signs are the same. So that's the way I remember it. Signs are the same. So if it's plus here, it's going to be a plus here. And then we have cosine of alpha multiplied by the sine of beta. So automatically we already know, since we have part A, we're given actually sine of alpha is 3/5. So we have 3/5 times the cosine of beta. Oh shoot, we already have the cosine of beta. So we have 3/5 times the cosine of beta, which is 2 radical 5 over 5. And then plus, we don't know yet the cosine of alpha, and we don't know yet the sine of beta. So that tells us, well, we've got to figure out what those are. So that's where we bring the triangles in. So whenever we're trying to figure out what the other trig functions are of the same angles, then we build a triangle. So we're told that the sine of alpha, which is 3/5, alpha being in quadrant 1, sine of alpha, so we build a triangle in quadrant 1, and we know that since the sine of alpha is 3 over 5, we know that the opposite over the hypotenuse is the sine of the angle. So 3 is the opposite leg, 5 is the hypotenuse, and that makes the adjacent leg 4, because we have a 3, 4, 5 right triangle. So since that's the case, we would know then that the cosine of alpha is equal to the adjacent leg 4 over the hypotenuse 5. And then we do the same thing for the beta. So we're told that the angle beta is in the 4th quadrant. So we were going to draw a triangle in the 4th quadrant, just like we keep doing, and put beta right there. And we're told again, cosine is 2 radical 5 over 5. So therefore we have to figure out, well, what's the y value? What's the other leg? So we would write 2 radical 5 squared, use the Pythagorean theorem. 2 radical 5 squared plus y squared equals 5 squared. And then what's 2 radical 5 squared? Well, 2 squared is 4. Radical 5 squared is 5. Plus y squared equals 25. And if we subtract 20 from both sides, we get y squared equals 5. And so we get y is radical 5. But don't forget, it's going to be a negative number here. So we're going to put negative radical 5 so we don't forget to put that negative in there. And therefore, the sine of beta equaling the opposite over the hypotenuse is negative radical 5 over 5. So all we have to do now is replace in our formula here. We will replace the cosine of alpha and the sine of beta. So we have 2 radical 5 over 5 there, and then plus cosine of alpha, we said that's 4/5, and the sine of beta is negative radical 5 over 5. And so we need to simplify this. Let's go ahead and notice that we have 5 times 5 as our denominator, so 25 is going to be our denominator. We're going to combine the fractions. 3 times 2 is 6, so we have 6 radical 5. And then minus sign here, so we're going to put minus 4 radical 5. So we get 2 radical 5 over 25.